AP Calculus. Today we are going to do an example, very simple example, but I think the simple examples will help you understand the concept better to do more complex ones. So basically we are going to find the area under a curve or bounded by more than one curves using integrals. Right, so here is our problem. I sketched it beforehand just to make the video go smoother. First function, f of x equals x, which I have drawn here. Second function, f of x equals 2, which is just a horizontal line going like that. And bounded by the y-axis, which is this guy over here. So bounded by this guy, and this guy. We are going to find the area of this. How do we do that? Well, just for the sake of learning integrals, we are going to use it using an integral. Sorry. Alright, so how do you go about this? You have learned before that the integral is essentially the area under a curve. So we are going to find the area of this curve, the area below this curve. So all of this minus the area of this curve. In doing so, we will find this. So always, if you're looking at two functions that are binding one area that you're looking for, always subtract the bottom function from the top function. So top function minus bottom function. Alright. We can start setting up our integrand. So obviously our bottom bound is 0 because we are told it is bounded by the y-axis. 0. But what is our other bound? Well, from the graph we can see that the bound is 2. But what if it's not that easy? What if it's not so clear? Then we can just set these two functions equal to each other. Luckily, these two functions are fairly simple, very simple actually. So x equals 2. Our top bound is 2. So essentially here we're finding where they intercept. So with more complicated set of functions, all you have to do is set them equal to each other to find where they cross at the x point. Now we got our bounds, we can set up our integrand. You know what I mean. So top function, this is our top function, and this is our bottom function. So top function is just 2 minus the bottom function, which is x dx. Alright, just a tip on the AP exam, on the FRQ section, when you are given a problem where you have to be setting up integrands, please do not forget the dx or the dy or the d, whatever you are using, because they will take points off for you if you do not set up your integrand correctly. They're not going to take off points, but they are not going to give you the points. So this little part right here, it's more important than you think. Okay, so how should we do this? Well, it's just simple integration actually. So this is just 2x minus 1/2 x squared. Alright, the next part, second fundamental theorem of calculus. Just plug things in. 2 times 2 minus 1/2, 2 squared plus c. Do not forget the plus c. Also, if you forget the plus c on the FRQ section, you will get points off, even though you know that the c's will cancel each other out. But yeah, it is important and don't exclude it. Minus 2, 0, minus 1/2, 0 squared plus c. Alright, so we can see here that the c's will cancel out because of the subtraction sign. So even though it will cancel out, just write it. Just write it, don't exclude it. Alright, so it's just 0. So we have 4 minus 2 is 2. This is your answer. If you want to be specific with units, so it would be 2 units squared, since it's area. Alright, here we go. How do we double check our answers? Well, in this case, we are given a fairly simple problem, so we can actually double check our integral using simple geometry. This is a triangle. The area of a triangle is 1/2 base times height. So 1/2 2 times 2, which is just 2. Of course, we cannot do this with all our functions. We'll be given crazy functions, but with this one, it is fairly easy. So geometry. The answers match? Yeah, they do. Alright. Hope that was helpful. Good luck. Bye.